This video will help you with the lab on locating the epicenter of an earthquake. This video will go over some of the more difficult things that are involved in that lab. One of the first things you need to do is calculate the difference in arrival times between the P waves and the S waves. And the seismogram is labeled nicely for you so you know exactly where each of them starts. The tricky part comes in determining the scale of this map. So this number indicates hours, the middle one is minutes, and the last one is seconds. So this would mark 20 minutes, this would mark 25 minutes. So this would be 21, 22, 23, 24, and 25. So the P wave, we need to estimate its arrival time, and it comes pretty much right along 21 minutes. So we can put that in our data table, the P wave arrival of 21 minutes. Let's practice that one more time by calculating the arrival time of the S wave. You can see the S wave arrival is here. If you lightly draw a straight line down to the scale, you can estimate to within 10 seconds of when this wave arrived. Here is the 30-minute line. This line would be the 31-minute line. So if you go about halfway, that would be 30 minutes, 30 seconds. But we are not at halfway. We are approximately at about 30 minutes, 10 seconds. So we are going to put that as the arrival of the S wave, 30 minutes, 10 seconds. Once you have the arrival of the P waves and the S waves, you need to subtract the arrival time of the P wave from the arrival time of the S wave to determine the difference in arrival times in order to help you continue with the lab. Sometimes that can be tricky. Let's take, for example, you have a P wave arrival time of 12 minutes and 40 seconds and an S wave arrival time of 24 minutes, 10 seconds. A really simple way to subtract this is to turn this number into 23 minutes. So we're taking away a minute and adding 60 seconds here. So it'll be 70 seconds. And that will be easier for us to subtract this number from it. So we can take away 12 minutes, 40 seconds. So the difference in arrival times then is 11 minutes and 30 seconds. This number then can go in your data table. Once we know the difference in arrival times between the P and S waves, which we just figured out, we can apply it to this graph to determine the distance to the epicenter in kilometers using this chart from our book on page 176. So in our first example, we had a difference in arrival times of 9 minutes, which is just barely on this scale. But before we use the scale, we should probably figure out what the delineations represent. So here we are dealing on the y-axis in minutes. If this is 1 minute and this is 2 minutes, then we can determine that this line would be 1 minute 20 seconds, 1 minute 40 seconds, 2 minutes. And on the bottom, on the x-axis, if this is 1,000 kilometers and this is 2,000 kilometers, this line here represents 1,200, 1,400, 1,600, 1,800, and 2,000. So every line represents 200 kilometers. Keep that in mind as you use this graph. So our difference in arrival time was 9 minutes. So we go up here to the 9, which is going to be the very top. We go across, and we will have to use kind of an eyeball measurement. I'm going to draw in my book. You should not do that. If we use an eyeball measurement and extend that line up a little bit, then we can get it to reach the 9-minute line, and then estimate a distance down below to be about here, which would give you 7,200 kilometers as the distance to the epicenter for this first seismograph. You apply this into your data table. The next step in this process involves using the map and a compass. To set up your compass, you need to put the pencil in, and these compasses have seen better days, so you do the best that you can. This black dial will loosen the pencil area. While it's loose, slide the compass points together, and you want the point of the compass to be even with the point of the pencil. Hold it there and tighten. Then you're ready to use the compass. So we learned from our first example that the earthquake was 7,200 kilometers away from San Jose. We're going to use the scale on the map to help us with that. Now this one is the trickiest one because our scale only goes up, and I increased it for you, up to 4,000 kilometers. But we need to get 7,200 kilometers. So you're going to put the point of the compass on 0, extend the tip of the pencil out to 4,000, but that's not enough. So what we're going to do is move the tip of the pencil to 0 and the compass point wherever it ends up. Notice that when I moved it, I did not expand my compass at all. I just slid the pencil to 0, and I'm going to hold that compass point very steadily wherever it ended up. So now I have the distance here of 4,000 kilometers. I need 7,200. So if I go up, this would be 5,000 kilometers, 6,000 kilometers, 7,000 kilometers, and I need 7,200. So I'm going to go to about there. Now I need to keep this distance on my compass very carefully and not budge it at all. Then I take a piece of cardboard, put it underneath. I'm sliding cardboard underneath the map. This is important so that you are able to hold the compass point in place. Then, since this is a reading from San Jose, you put the tip of the compass point on San Jose, hold it there firmly, again being very careful not to move the width of that compass. And it helps to angle your compass as you draw your circle. You can see this circle is going to go way beyond the paper, so we just need to keep it on the paper like so, down to the bottom. We don't need to make this one as large as necessary or a complete circle. It only needs to be on the map. You're going to do that same thing for the other two earthquakes, and where the three circles intersect somewhere on this map, you will have the epicenter of your earthquake. Then you can continue the rest of your lab using whatever you need to answer the questions. Good luck.